I'm the host now. That's good. Okay. I don't know if that's going to help. Hopefully it does. Try to share my screen again. OneDrive is processing 83 changes. Why the heck is it processing so many changes? That's what's slowing my internet down. It's all the OneDrive crap. Maybe I can stop it. Stop OneDrive. It's pulling all my internet. Stop. Oh, it's Zoom. It's trying to convert Zoom. I don't want to convert Zoom. Zoom sucks. Stop. Stop uploading. This file is in use. So Zoom is wanting to upload to OneDrive, which is causing it to not want to work. Okay. I don't know why. Let's get rid of all this crud. Delete. I delete you and your badness. Can't, because it's being open. It's open in Zoom. That's great. Zoom is awful. I hate you, Zoom. I hate you. I hate you with passion. I passionately hate you. Okay, well, let's see. Let's see what we can do with this, I guess. Tired of wasting any more class time. Okay. Let's share it. Sharing is caring. Okay, let me know what happens here. Okay, other questions. We did number 3, we did number 2. Any others that you'd like to see done? I'm gonna stop my video again just to make sure that my RAM is not being completely munched up. Okay, 10 and 11 says Achilles. Okay, sounds good. Okay, number 10. Number 10. Want to do some integration here. That's good. Integration is always fun. Okay, 11. Really, 11? 11 is just, 11 is a nothing. 11 is nothing. I'm not going to do 11. It's just make a little fish, little ichthus. Just reflect it. For number 11, just reflect along the line y equals x. Here's number 11. Okay, boom, boom. There you go. I'm done. That was easy. Okay, number 12. No, number 10. Sorry, number 10. Number 10 is, let's do the integration from 0 to 2 of e to the x over 1 plus e to the 2x, right? Okay, so what is my u substitution going to be here? Well, u is equal to e to the x. Why? Because I can rewrite this guy as 0 to 2 of e to the x all over 1 plus e to the x squared. Okay, dx. Don't forget my dx. Okay. Okay, so now what does this become? Well, what's du? du is equal to e to the x dx, which is what I have here. So that's my du. So this becomes e. I can plug in 0 and 2 in for x here to get my limits of integration. This is going to be 1, and this is e squared. Okay, and so this is going to be 1 over 1 plus u squared du. That is arctangent. That is inverse tangent. That's the inverse tangent of u evaluated from 1 to e squared. Okay. Okay, so I'm going to plug this in. This is the arctangent of e squared minus the arctangent of 1. But what is the arctangent of 1? We want the angle whose tangent is 1. That's what arctangent is asking. The angle whose tangent is 1. Well, what's the angle whose tangent is 1? It's pi over 4. So this is just the inverse tangent of e squared minus pi over 4. Okay. Good. Okay, others that you'd like to see done? Any others that you want to see done here? Okay. On 8, the answer says e to the 5th, but I get e to the x. It sounds like a personal problem, Victor. I'm just kidding. Let's do number 8. Okay. Okay. So you're getting e to the x. I don't know what you're getting. Okay. So maybe you're writing the problem down wrong. To the, okay, let's look at the problem real quick. Because you might be writing the problem down wrong. It's hard to read. It's actually a hard problem to read, number 8. So let's see what we get here. Hello, open. Open, open, open. You do now. Okay. So number 8. Okay. So we have to make a determination, okay, as to what the heck this thing is. Where are we? Number 7? I'm on number 8. Find g prime of x. Now, is that a s or is that a 5? Okay, that's the real question. Is it an s or is it a 5? Okay, I'll go. Yeah, I used 5. Oh, I thought it was a 5. Okay, it has to be s. Yeah, it has to be s. That's the problem. I think that it's just the fact that the pixels are too small. Okay, in order to get the right answer, okay, I believe it has to be an s. I think. Let me look at this for a second. Okay. Okay, so I'm thinking that it's an s myself. Okay. Okay. So yeah, so that's just it's hard to read there, but it is an s. Let's see what happens when we integrate this bad boy here. Okay. So okay, and so what we're getting is okay, the derivative of the integral, right? So we're going to use some fundamental theorem of calculus there, from 3 to radical x, right? So this is e to the, okay, so we've got g prime of x, 8. G prime of x is equal to d dx of, my internet connection is unstable, that's wonderful. Okay, d dx, okay, of the integral 3 to radical x, okay, e to the s all over s ds. Okay, so now we're going to integrate and then differentiate, right? Integrate and then differentiate. So we would integrate, right? We would integrate. So say that little f of s is equal to e to the s over s. Then a big F of s would be equal to something. Okay, I don't know what that is, but that would be the antiderivative. Does that make sense? Okay, that would be the antiderivative. So if I were to do the antiderivative here, it would be big F of radical x minus big F of 3, right? Does that make sense? The antiderivative evaluated at radical x minus the antiderivative evaluated at 3. However, when I take the derivative of this, right, well, what I get? Well, here, this thing is a constant, so that goes to 0. This thing would be the chain rule. Okay, this would be the chain rule. So this would go back to f of radical x times the derivative of radical x, which is 1 over 2 radical x. Okay, so this would be e to the radical x all over radical, gosh darn it, all over radical x times 1 over 2 radical x, which is going to be e to the radical x over 2x. Okay, and I guess I need to change this. Like, let me update this real quick so that this looks like a freaking, I don't know if it's going to let me do just one piece of it. It's probably just going to make it an image, the whole thing. But anyway, yeah, it's just going to make the whole thing an image. It'd be really nice to write over this with, you know, but I need to figure out how to do that. Make it look more like an S. Okay. Okay. Let's go back to 100%. 103%. I just want 100%. 125. Okay. Okay, others that you'd like to see done? $14 and $15. Okay. Oh, let's do 15 first. Okay. Let's do 15 first. Okay, number 15.
Professor, the final answer to be e to the root 3 or e to the 3?
Say that again.
The final answer will be e to the 3 or e to the root 3. Root x?
No, there's no 3 in it.
Yes, because...
Because when you take a derivative of a constant, you get 0.
Oh, yeah.
Okay, number 15. Okay. F of x is equal to x e to the negative 3x, okay, from negative 1 to 2. Okay. And what are we doing here? We're wanting to find an absolute minimum and an absolute maximum, right? We want to find our mins and maxes, right? Will there be an answer key posted? I don't know what you're talking about. Thank you, Melanie. Okay, whatever. Okay, f of x is equal to, and we want to find the min and maxes on this interval. Okay, so we're going to take the derivative, set it equal to 0, and then get our critical values, and then use the mins, and maxes. Okay. Okay. So we're going to take the derivative here, f prime of x. Derivative of the first is 1, that's e to the negative 3x, plus x times the derivative of the second. Well, that's just going to be negative 3x e to the negative 3x. I'm going to set that equal to 0. I'm going to factor out an e to the negative 3x times 1 minus 3x is equal to 0. Okay, this thing is never 0. This thing is never 0, so we can pretty much drop it. Like, we can divide by it, basically, e to the negative 3x, e to the negative 3x, that never goes to 0. Okay, so we've got 1 minus 3x equals 0, so x is equal to 1/3. Okay, so 1/3 is our critical value. Okay, that's our one critical value. Okay, the other thing that we have to do is we have to test our endpoints. We have to test -1 and we have to test 2. Okay, so I'm going to plug these in to my original function, f of -1. Okay, that's going to be e to the negative e to the 3 if I plug that in. Okay, f of 1/3 is going to be 1/3 e to the negative 1/3 times, sorry, e to the -3 times 1/3, -3 times 1/3. Okay, that becomes 1/3 e to the -1, which is just 1/3e. Okay, so we're going to need to find out what an approximate value of these are. Okay, well this thing is negative, so I know that that's going to beat this thing out. Okay, and then what's f of 2? Okay, f of 2 is going to be equal to, okay, going back here, that's going to be 2 e to the -3 times 2. 2 times e to the -3 times 2. That's going to be 2 over e to the 6th, right? 2 over e to the 6th. Okay, so I want to know what's big and what's low here. Well, I know that the -1 is going to be my minimum value, right? Because that has to be the min. So the absolute min occurs at -1, negative e to the 3. That's going to be my minimum value. Now I just need to find out, well, what's my maximum value here? Okay, is it 1 over 3e, or is it 2 over e to the 6? Well, this thing is going to be a huge number. 2 is basically 2. So we're taking a small number divided by a big number. We're going to get a really, really small number here. Okay, so I'm going to say that this is going to be 1/3. 1 over 3e is going to be my max. Okay. Say what? It's -3. Is it not? I don't know what you're asking. Honestly. The first part? It's x e to the -3x. Okay, I'm just going to go with what I have because it's what's right. You took the derivative of -3x and put 3. Did I though? Let's see. I took the derivative of -3x and put 3. How the hell did I do that? I see a -3x here. No, I didn't. I don't know what you're talking about, Victor. The negative sign is little. Yeah, it's a little negative sign. Okay, it's there. Look closely. You want me to zoom in? It's right there. Okay. Other questions? Other problems that you'd like to go over? Okay, 14. Okay. Let's do 14. Okay. So 14, we want to do what? We want to just find the derivative of this thing? Okay. So we have y is equal to x plus 1 squared times 8x to the 7. Is that right? Or is it a squared? 8x is, oh, it's squared. Okay, 8x squared minus 5 cubed. Okay, minus 5 cubed. X plus 1 squared times 8x squared minus 5 cubed. Okay, hopefully that's right. Yeah, okay. So we're going to use logarithmic differentiation to, it says use logarithmic differentiation, so that's what we're going to do. Okay, we're going to do exactly what it told me to do. Okay. Okay, so let's take the natural log of both sides. Okay. Okay, so natural log of y is equal to the natural log of x plus 1 squared times 8x squared minus 5 cubed. Okay, so this allows me to write this as natural log y equals 2 natural log of x plus 1, okay, plus 3 natural log of 8x squared minus 5. Okay, the derivative of, now we're going to take the derivative of both sides, d dx of everything. Okay, d dx of everything. So this is going to be y prime over y. Okay, this is going to be 2 over x plus 1 plus 3 over 8x squared minus 5 times the derivative of the bottom here. Well, the derivative of the bottom here is 1, so if you really want me to do the chain rule on that one, I can. It's just going to be a 1. The derivative of 8x squared minus 5, that's 16x. Okay, and so this becomes y prime is equal to, I'm going to multiply both sides by y. This is going to be y times 2 over x plus 1 plus 48x over 8x squared minus 5. Okay, but what was y? Y was x plus 1 squared times 8x squared minus 5 cubed. Okay, so let's distribute this. This is going to be 2 times x plus 1 times 8x squared minus 5 cubed plus 48x times x plus 1 squared times 8x squared minus 5 squared. That's y prime. Okay. Okay, and then somebody asked for 12. Okay, so what do we want to do? We want to find out where these intersect or something? I don't know. What do we want to do here? We want to, okay, find the points of intersection of the graphs of the function. Express your answers accurate to 1 decimal place. To how many decimal places? To, oh no, 1, 2, 3, 4, 5 decimal places? Okay. Oh, you read the wrong one? I used the calculator for 12. Okay, sounds good. Perfect. What did I do? I just set them equal to each other and solved. That's all I did. It's not really a calculus problem, so you can get rid of that one if you want. Okay. It's more a graphing problem. Okay, yeah. Let's go over number 19. Number 19, you're definitely making it harder than it should be. Okay, it's a two-line proof here. Okay, number 19. Okay, we have the secant. Oh, what the heck happened there? Okay, the secant of the inverse sine of 8x. Okay. Okay, so the inverse sine means we want the angle whose sine is 8x, right? Does that make sense? The angle whose sine is 8x. Well, what is 8x? Let's put this 8x over 1. Wouldn't 8x be the opposite and 1 be the hypotenuse? Right? So if I looked at a triangle here, the opposite would be 8x and this would be 1. So how could I get the bottom of this triangle? Well, Pythagorean theorem, right? So wouldn't this just be a squared plus b squared equals c squared? Okay, so this is going to be a squared, which we'll call the bottom a here, a squared plus x squared is equal to 1 squared. So a squared is going to be equal to 1 minus x, 8x squared. Sorry, that's a squared. Okay, so that's 1 minus 64x squared. And then let's take the square root, right? Why don't we want the negative? Because distances here are not negative. Okay, and also the inverse sine function, okay, it goes from negative pi over 2 to pi over 2. So we're going to keep things positive there for our x values. Okay, our x values have to be positive, and that's what the cosine function here is. Okay, or the a value there is, right? Okay, so what's if this thing here, if a is equal to the bottom here, which is the square root of 1 minus 64x squared, then what's the secant? Well, the secant of that is going to be hypotenuse over adjacent. Well, secant of theta is equal to hypotenuse over adjacent, which is 1 over the square root of 1 minus 64x squared. And that's it. Boom, you're done. Does that make sense? Okay. No, this is good. This is good because this sets up what we need to do in chapter 7 after the exam. Okay, something called trig substitution. Okay, 18, yeah. For Melanie, anything. Okay. Because Melanie helps me ask questions or answer questions. Okay. She takes some of the burden off. Anything for Melanie. Okay, let's do the integral, okay, of x plus 1 times 2 to the x squared plus 2x dx. We want to integrate this, right? Okay, cool. Awesome. Okay, what's our u going to be? Our u is going to be the exponent here. That's x squared plus 2x. Okay, what's du? du is going to be 2x plus 2. Okay, and that's going to be dx. Let's factor out a 2 here. Okay, 2 times x plus 1 dx is equal to du. Okay, so let's divide by 2. I get du over 2 is equal to x plus 1 times dx. Now, why is that important? Because that's what I have here. Oops. That's what I have here. Okay, so I have my u, that's this thing, and my du over 2, that is this thing. Okay, so this just becomes the integral of 2 to the u du over 2. Right? Okay, so I'm going to pull the 1/2 out in front and then take the integral of this thing. Well, that's just 2 to the u natural log 2. Okay, plus c. oh, sorry, it's 2 to the u over, I did the derivative. It's 2 to the u over natural log u. We want to do the integral. 2 to the u over natural log u of 2, sorry. There we go. So this thing just becomes 2u over 2 natural log 2 plus c. Okay, now we can plug back in our x value that we started with. And so this is 2 to the x squared plus 2x all over 2 natural log of 2 plus c. Now, if I really wanted to, okay, I could leave it like this. This is fine. Or I notice that I'm taking a 2 and dividing by a 2 to the first. So if I wanted to, I could really write it like this. 2 to the x squared plus 2x minus 1 all over natural log 2 plus c. Okay. And does that factor? I don't know if that factors. Does that factor? No, it doesn't factor. Okay, it'd have to, the signs would have to be reversed in order for it to factor. So it does not factor, so we're good. Could stop there. Okay, either of these will be acceptable. Okay.
Professor?
Yes?
How did you, just curious about how you got 1/2 times 2u over ln2? Natural log of 2, my bad.
1/2
And then,
over, yeah, it's just an identity. 2 to the x, when I integrate 2 to the x, it's 2 to the x over natural log of 2. Okay, anything that's, I'll just do the general. Integral of b to the x is b to the x over natural log of b plus c. That's just an identity.
all right, cool. Thank you.
Okay. Okay, 17. Okay, let's do 17. Okay, number 17 says we have y is equal to x to the 2 over 7 over x. Y equals x plus 2 to the 7 over x. And I assume we're just taking the derivative of this thing, right? Okay, so again, because we have an exponential, I'm going to want to use logarithms. Okay, so ln y is equal to, okay, natural log of x plus 2, 7 over x. Okay, natural log y is equal to 7 over x, natural log of x plus 2. Okay, I'm going to rewrite this. I'm going to go natural log of y is equal to 7x to the negative first, natural log of x plus 2. And now I'm going to use a product rule on this one. Okay, I'm going to implicitly differentiate. This is going to be y prime over y is equal to, this is going to be derivative of the first, that's going to be negative 7 over, or let's just do negative 7x to the negative 2 for right now, times natural log of x plus 2 plus, okay, 7, okay, 7x to the negative first times the 1 over x plus 2, okay, which is the derivative of natural log of x plus 2. Okay, so this thing becomes, okay, natural log of x plus 2, negative 7 natural log of x plus 2, all over x squared, plus 7 all over x times x plus 2. Okay. Okay, and then I'm going to multiply through by y. I'm going to multiply y to both sides. Okay, so multiply y to both sides. Y prime is equal to, well, what was y? Y was equal to x plus 2 raised to the 7 over x power, right? Times, okay, natural log negative 7 natural log of x plus 2 over x squared plus 7 over x times x plus 2. Okay. And I'm going to distribute this guy. So y prime is equal to negative 7 x plus 2, 7 over x times natural log of x plus 2. Okay. Natural log of x plus 2 all over x squared. Okay, plus, okay, 7 times x plus 2 to the 7 over x. Okay, all over x times x plus 2. Okay, and so the last thing that I can do is just reverse the order here. Y prime is equal to 7 over x plus 2 to the 7 over x. Okay, times the natural log. Oh no, not times natural log. Divided by x times x plus 2. Okay, minus 7 times x plus 2 to the 7 over x times the natural log of x plus 2 all over x squared. I could find a common denominator if I really wanted to. I don't know how much that's going to help me in the long run. Okay, I could actually get rid of the x plus 2 here, though. If I went like this, I could go 7. This is the answer that they had, that the people who first worked the problem had. You could maybe tidy this up a little bit more by going 7 times x plus 2 to the 7 over x minus 1, because we've got another x plus 2 here. Okay, all over x. No, you don't. Okay. Okay, minus 7. Okay, so I'm going to put an x here, and I'm going to put an x squared there, and then I'm just going to put it all over a common denominator. Minus 7 times x plus 2 to the 7 over x times natural log of x plus 2 all over x squared, and that's about as simplified as I can get it. Okay. Yeah, exactly. Thank you, Sarah. Okay. Sound good? Okay, you want to see me do 12? 12 is just plug it into Desmos, bro. Okay, but if you really want me to do it, I can do it. So let me go to Desmos here. Yes, that is true. You get 2 tries to get the right answer on the exam. Okay, pretty sure. It's 2 tries. I can verify that for you. I was going to verify it tonight anyway, but I can verify that right now. Okay, sign in. Okay, and there's my exam. Go to my assignments, go to my chapter 6. Okay. Okay, there are 12 questions on the exam, just to let you know. Okay, and I'm going to view my settings here. Okay, submissions allowed 2. There are 2 submissions allowed. Okay, now I don't know if that means you get 2 submissions per, it says submitting answers, questions, new or changed question parts, new or changed questions question parts can be submitted individually. Okay. Scoring answers, use student's last answer. Okay, that's good. Yeah. So I think that you can, you know, hit the answer. I don't, on the exam, the only place to hit submit though is it's not a submit question to question. It's you go through the whole exam, you click submit, and then it'll tell you which ones you got wrong. And then you go through the ones you got wrong again, click submit again, and it will obviously take more of your answers. So you don't want to change the ones that come up green checks. Obviously, if you change those, you're dumb because you're just changing the right answer to a wrong answer. Okay. Or I don't know if it'll save. It should save your answers. It'll say it'll give you feedback of whether or not you got that one correct or not. Okay, it'll give you a green check or a red X. Okay, but as you're writing these down, you're going to have the answer in front of you as well. So you have 2 submissions for the exam. Okay. No, there are no sub questions. I don't believe. I don't know. I'd have to go through every single one. Okay. But they're just individual questions. From the most of my knowledge. I mean, I could sit here and look at question by question, but does it really matter? Because each question is worth 8 points. So even if there are sub questions, they're just going to get halved or quartered or whatever. So, I mean, I can view it. I can view the exam and see. I mean, I wrote this exam 3 months ago, so I'm not real. Like, there's even one yes or no question just because I'm giving you pity points on that one. So, like, you're going to have to show your work though, but it's still just yes or no. Is it right or wrong? So some of them have 2 answers. Some of them have one. Most of them have 1. There's one answer, one answer, one answer, one answer, one answer, one answer. Give me the derivative, show me the domain. That's a 2 answer. Answer, one answer, yes or no question. Give me the first derivative, give me the second derivative. That's a 2-parter. Okay, and then give me the first derivative. That's it. Boom, done. It shouldn't be too freaking hard. Okay. Let's get a sneak peek of the test. Oh, sure. Okay. How about $100,000? Do you have $100,000? Because that's what it would cost to replace my salary for 2 years. Okay. If you can, you have $3? No dice. Sorry. Oh, sorry. Okay, any other questions that you'd like to go over? At this point in time? You just need to study. You just need to study, right? Question 1? Oh, okay. Question 1. What was question 1? Okay, let's go. Oh, yeah. This is a good one. I like this one. Yeah, we should go over question 1. Okay, that's a good one. I like this one. Okay, so we want to find the derivative of g prime of 3, right? Given What are we given here? Okay, we want to find, suppose that g is the inverse function, right? And we want to find g prime of 3 given all this information. Okay. Okay, so we have, yeah, let's go over this one. Okay, number 1. We get a thinner pen here. Okay, so F inverse, okay, first we're going to look at what's F inverse of A. Okay, F inverse of A. Okay, is equal to, or sorry, F prime, F inverse prime, right? F inverse prime of A is equal to our famous formula 1 over F prime of, okay, F inverse of A. Okay, but in this case, we're calling F inverse of A G, little g, okay, G of A. So F inverse of A, we're going to call little g of A. Okay, little g of A. Okay, so what's G prime of A? Well, G prime of A is going to be 1 over F prime of G of A. Okay, F prime of G of A. Okay. So we know that F of 4 is equal to 3. Okay, F of 4 is equal to 3. That tells me that G of 3 is equal to what? If F and G are inverses, then yeah, then it's 4, right? Okay, so we're going to say that G prime of 3 is equal to 1 over F prime of G of 3, which is equal to 1 over F prime of 4. But don't they tell me what F prime of 4 is? They tell me that F prime of 4 is 1 over 16, right? 1/16. F prime of 4 is equal to 1/16, I believe. So this is going to be equal to 1 over 16, which is equal to 16. Okay. Okay, so now I want G. I want to know, well, what's G of X? Okay, what's big G of X, right? We've got little G of X here. I want to know what's big G of X, or the, okay, the okay, and what do they tell me? What do they tell me in the problem? How do those two relate? Okay, they say that big G of X is just 1 over G of X. Okay, so big G of X is equal to 1 over G of X. Okay, so that's how those two relate, right? Okay, so we're building it. So G of X is equal to 1 over G of X, okay? Which is equal to G of X to the negative first power, right? So how do I get G prime of X? Well, isn't G prime of X then equal to, chain rule, negative 1 over G of X squared times G prime of X? Isn't that how we would do that? Okay. So now, what do we know? Well, we know that G of 3, is there a question here? Glitchy audio? Glitchy audio, okay. We had glitchy video, now I have glitchy audio. Okay, I'll test my speakers. Do I hear that? You hear that? Testing, 1, 2, testing. Okay, I hear myself as well. Okay, it's all good, thank you. Okay, so now it's Zoom. I'm blaming Zoom, okay? I'm blaming Zoom, I blame for all my problems. Okay, The ultimate scapegoat. So what was g of 3? Well, this is -1 over g of 3. Well, wasn't g of 3 4? And what was g prime of 3? Well, g prime of 3 we found was 16. So this is -1 over 4 squared times 16, which is just -1. Boom. That's a nice problem. I like that problem. Okay. Does that make sense? If it doesn't make sense, rework it, and then you can come back and you can ask me again at 1:30 tomorrow. Okay, but rework it tonight. Yeah, that one makes you think, exactly. Okay, things that make you go, Okay, where's my easy button? That was easy. Okay, there you go. Got my easy button. That was easy. Of course it was. Okay. Will most of the problems be the same difficulty as a review, or will it be homework level? I don't know. What was the difficulty level of the homework? Veteran, very hard. They will be review level. Yeah. They will be review level. Okay. Okay, any others at this point? I mean, the rest of them, I don't know. You should be able to do. I mean, I think I don't know. If you guys are good, I'm good. But okay, question 9. Didn't we didn't do question 9? No? What is question 9? Okay. Yeah, let's do question 9. Okay. Let's do question 9. Okay, let's see what we got here. Question 9. Okay, so we have y equals, what are you trying to do here? Just find the derivative? Is that it? Okay, so y equals natural log, natural log of x to the 5th sine x squared, natural log x to the 5th sine squared x. Okay, so there's multiple ways to do this one. I don't know which way you want to do it at this point. So I'm just going to do it the way that I've done it here. I don't know. I mean, it's just kind of like, yeah. Because you could break this up. You could break this all up, right? If you really wanted to. I don't know. Let's try it. Let's try it a different way and see if it works. I don't know. 'Cause I did it a long way. There might be a faster way to do this thing. Okay. You got confused? Okay. Well, let's do it the easy way. Let's see if we can do it the easy way. And maybe it doesn't work. Maybe it doesn't work out. Okay, so I'm thinking that it's natural log of x to the 5th plus natural log of sine squared x. Can I do that? Is that allowed? I think that's allowed. Okay, so 5 natural log of x plus 2 natural log of sine x. Okay. Okay, so this is going to be equal to 5 over x plus 2 over sine x times cosine x, right? Okay, now let's get a common denominator here. Okay, this is going to be 5 sine x plus 2x cosine x all over x sine x. That's it. Boom. Okay, that's easy. That's it. That was the easy way. Okay. I'm going to write the easy way down in my notes because I did it the hard way. But that's because I did this before I taught it. So it always happens on a question or two that I'll do it and I'll be like, oh, that's not the easiest way. So yeah. Okay. Okay, let's call it a day unless you have others that you absolutely want to do here. Okay, question 4. Okay. Let's see, question 4. Okay, question 4, are you kidding me? That's a pre-cal question. I'm not doing pre-calculus. Sorry, Joseph. Okay, you go look it up in a pre-cal book. Okay, I don't teach pre-cal. Sorry. It's the same thing that we've been doing. We've been just breaking it up. Okay, with our logs. Yeah, look up log properties, exactly. Okay. Okay. I don't go down to the pre-cal level, not during summer school. Sorry. Okay, well, that said, I'm gonna end it there, if that's okay with you guys. Okay, and I will see you, see those of you that want to show up at 1:30 tomorrow. Okay, and the test is at 2:30 tomorrow. Okay, see you guys later. Bye.
Mr. Holtman?
Yeah, question?
Yeah, I had a quick question about the YouTube. Would you be able to post this? My connection was going in and out, and for some parts I wasn't able to be here. So I was wondering if you could post it.
I can post everything after the water checkpoint.
Okay.
If that makes sense. I can't post anything before the water checkpoint because that's when my internet crapped out.
Yeah, that's
okay.
good.
Okay, sounds good. Yeah, I'll convert this and then I'll post it tonight.
Sounds good. Thank you.
Okay, bye.